the first part of this was finding a volume with given cross sections. Okay, so they would give us the shape of the cross section, and we'd work from that piece, and then basically take the integral of the base area. Okay, so this second half of this is the idea of revolving a function around a line. Okay, so I actually have a very excellent manipulative here to explain what the idea of this is. Okay, so if I was going to say we're going to take the area of x squared, okay, and let's say it's just defined by, I don't know, y equals 5, whatever this happens to be. Okay, and we're going to take this and we're going to revolve it around the y-axis. What's going to happen is it's going to create a three-dimensional shape. Okay, so these are what we're looking to find. So things can get really crazy awesome if this shape becomes something different than just a parabola, right? If I have, let's say, like a sine or a cosine function where there's wave, this piece is going to kind of look like bubbles. Okay, so that's the idea of what we're doing. Okay, so we still need to know the cross-sectional shape. Okay, so if I turn this over and we're going to look at the cross-sectional shape of something that's been revolved around an x-axis, what is the shape of our cross-sections? Always. Okay, so our cross-sections will always be circles when we're revolving something around an axis.
Wait, so what if not when it's like this?
Well, it would still, because, like, let's say my function is like, you know, like a sine curve where we have bubbles. So like it would go in and come back down. Do you see what I'm kind of saying? It would still revolve around this. So if I look this way, the cross-section wise, there's still circles in there. But the volume shape is going to look like bubbles, little bubbles everywhere. Does that kind of make sense? Okay. So the hard part of this is to visualize the three-dimensional shape. But we can still get by as long as we understand what's happening. Okay? So, let's do a quick example here. Okay? So, let me have you write this down. So, the first thing that we're talking about, they're going to call this this three-dimensional shape, which you just said was what did you call this three-dimensional shape? Or this shape right here, it's a circle, right? So they call it a disc.
I disagree.
Which in my opinion is not the greatest word to use as a disc, because a disc is like a frisbee, or you could think of it as like a pizza. Okay, so would you agree that a circle is kind of like a pizza?
Yeah.
Sorta. I mean, yeah. Like if you were just looking at the 2D, then a disc. Yeah, pizza's kind of fun. Okay, so we got a pizza here. So you're writing this down in your notes. The volume of this is always going to be pi r squared. Pi r squared. Now notice that I have a big R. What do you think this R is?
Radius.
Okay, it is the radius. It is the radius of the circle, which is going to come from the base. Okay, so this is the radius. You're right. Which comes from I'm going to call it f of x base. All right. Did you write it down?
No.
Your projector thing has bad color.
Yeah, it's not as good as my OneNote colors, is
No,
it?
even my OneNote on
That's what you get on a projector. All right, here we go. So, is everybody with me? Focused? All right, so we have the volume of a solid. Okay, we're given this equation, and this equation is going to be revolved around the x-axis. Okay, so the first thing I'm going to do is I'm going to draw the base, just like what we've done on every single one of these sections. I'm going to draw the base so I can kind of get a visual. Okay, it helps me with my integral bounds. And then I'm going to kind of think about what's going to happen as I revolve this function. Okay, so if I was going to graph my y, x squared plus 3, what does that look like?
Start at 0.
Starts at, well, what? 0, 3, yeah, okay. And then kind of projects up like this, so we got a parabola, right? Ooh, that was a good parabola. Okay, and then I have the equation y equals 0, so what does the equation y equals 0 look like? Okay, so yeah, it's like the x-axis. And then I have the equation x equals 1, what does that look like?
Vertical line at 1.
Vertical line at 1. And then I have another vertical line at 2. Okay, so here is this base space. Okay, so the idea, are you ready to visualize?
Yes.
Is that I'm going to take this area and rotate it around the x-axis. So can you imagine what this three-dimensional space looks like?
No.
So if I take this area and rotate it around the x-axis,
Oh,
It's gonna be like a skinny.
It's gonna be like a circle.
looks like a circle. It kind of looks like a plate, like
Yeah.
a flat plate. Okay, and kind of like the edge
Like
of it is
one
tapered down, right? You kind of see what I'm saying by a flat plate. Okay. All right, so we're gonna set up the equation. Okay, the volume of this is going to be, we're doing a pi r squared. I like to pull the pi in the front because if I ask you to do this by hand, which I'm gonna have you do, it's gonna be way easier to work with this out in front. Okay, so I'm doing a pi r squared. Give me the x values that binds this space.
1 and 2.
It exists between 1 and 2. 1 and 2. And now I need an r squared. Okay, so remember that my plate has been rotated around the x-axis. So what is the length of my r? What is my length of my r? Yep, rotating it around the x-axis.
4 and 6. 5.
It's not a constant radius. What is the distance of my radius?
Oh, it's like 2.
Okay, the radius is going to exist from the x-axis to the top of that curve.
So 4.
So what's the length of this?
4.
4? You need an equation. It's not a constant distance.
X
4,
squared
5.
plus 3.
There you go. It's x squared plus 3. Okay, so it comes from the equation. It's a top minus bottom, same idea. Okay, so the radius is literally our equation. X squared plus 3. And since we're doing r squared, dx. Is everybody okay on that setup? Okay, I need somebody to type that into the calculator and tell me what that is equivalent to.
So you put pi first and then.
I do put pi first. I like to put the pi in the front because when I ask you to do this by hand, it will be easier to work with. And it is coming, by the way. We will be doing it on the review.
Why?
Practice. Gotta know how to integrate.
But integrate.
I don't remember.
What'd you get? 91.73. Okay, and by the way, will I be able to write this as a fraction?
No.
Why not?
Because pi.
Yeah, because there's a pi involved. So the only way for me to have written this like a fraction is to write it in terms of pi. Okay, so if you're using the calculator does not have that ability. So there's a way I will know if you're doing things by hand or on the calculator. Okay, if you give me an answer in terms of pi, I know you can do this by hand. If you give me a decimal answer, I know you can do this in the calculator.
So that would
the
that
answer is
answer
wrong.
been with pi?
Depends on who you ask.
I mean, it will equal each other, so it's not wrong.
That's faulty. What
Did
would
you?
that have been in the pi?
There's got to be a pi. Where's your pi?
No, if you do it in the calculator, you just divide by pi.
What would that answer
Or you
been?
could just do, if you did it in the calculator, you could just not use the pi, do the integral, hit the fraction, and then do whatever you said, pi over whatever. Okay, should we do another one? Let's do one more. Let's see how this one is. We should be able to rock through this. Don't you think?
I'm so confused.
You're so confused?
You have no idea.
Oh, well, let's keep
Wait, you
going.
should go back.
Last time.
Was there anything left?
So all we gotta do is square stuff pretty much.
Yeah. So the nice thing about doing the revolving stuff is the cross-section shape is always the same. It's always a pi r squared, so it's not as fancy as the last section we just did where we could have potential squares or equilateral triangles or semicircles.
It's all gonna.
So it's just a circle.
I like that.
Yeah. All right, so pi r squared, cross-section of the circle. Okay, so what does the equation of square root of x look like?
Oh, it's the one that starts at 0, 0, and then goes up at a half parabola.
At a half parabola on its side, right? Good. So it looks like that. Okay, then what does y equals 0 look like?
The x-axis.
That's just the x-axis. And what does x equal 4 look like?
Straight line up and down.
Okay. So here's our space. That's the space we're going to revolve around the x-axis. So that actually looks like, look at my little thing here. There it is. Look at this. There's my space between 0 and 4. We're revolving it around the x-axis. There's our visual. Okay. So let's set it up. Let's go straight to the integral. What's my integral going to exist between?
0 and 4.
Okay, good. Between 0 and 4. Whoops, I forgot my pi. Pi times the integral of 0 and 4. What's the height of my radius?
Your x, you square root of x squared.
I got you.
Oh yeah, that's like an arrow for revolving. Did everybody say the square root of x?
I said that.
Okay, good. Okay, and then we need a square because it's pi r squared. Right?
So then,
Pi r squared.
if you did that,
Not too bad, right? Okay, throw it in your calculator. Tell me what you get. Right. Always, when we're doing a circle.
Always. Pi r squared.
Right.
Wait,
Still alive today. They got the wrong guy.
I don't care.
Wait,
What do you got? You got them both? I like pi if you got it. 8 pi what? Oh, exactly 8 pi. Oh yeah, we could do this one. Actually, we could do this one really easily, like mentally. Could you do this one in your head? Think about this.
Wait, how? Show me how to do it.
What's the square of x squared the same as? X. So technically, all we're doing is integrating x. What's the integral of x? Remember, you add 1 to the exponent and divide by that same number. So it'd be 1/2 x squared. Right? And then all I have to do is plug 4 into it, because if I plug 0 into it, it will be 0. So I have 1/2 of 4 squared, which is 16 divided by 2, which is 8. So this gives me 8. And then I have pi. Pi, you can do that in your head.
What? No, if I put like 25 by 1
No, because that's the same as 8 pi.
Wait, how'd you do it in your head?
Because so like the square root of x squared is just x, right?
Yeah.
So then we integrate. What's the integral of x? 1/2 x squared. From 4 to 1. Then I just do top, because if I plug 0 in, it's going to give me 0, right? 4 squared. So it's 8 pi, yeah. That one's pretty straightforward. Okay, let's do one that's a little bit, cooler. Okay, so every so often I'm going to make you do it around the y-axis. Okay, so remember the warm-up today? When things are perpendicular to the y-axis, what does our integral have to be in terms of? Of y. Okay, so you really got to think about this. Okay, so, oh wait, this isn't the example that I was looking for. This is still revolving around the x-axis. So make sure that you read that there is a problem on your homework that is revolved around the y-axis.
Wait, so are you doing this? That's
Okay? Oh, yeah, sorry. The given, sorry, my bad. The given axis. So, okay, so let's go ahead and do this one and I'll show you. So what does negative x squared plus 6 look like? Upside down. Dun, 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 dun. Crosses. I think it crosses right at 3, doesn't it? No, it doesn't. It's not a nice cross. Something like that. Okay, what does the equation y equals 2 look like? Y equals 2.
It's a straight line.
It's a straight line at 2. Thank you. Okay, what about the equation x equals 0? Hey. Jeez, how rude. There we go. Straighter. X equals 0, and then x equals 2. So this actually should cross at 2, shouldn't it? Oh, no, it doesn't cross at 2. It doesn't. It's not exact. It is kind of rude. Okay, so we're going to take this area right here, okay, that's bounded by those 4 lines, and we're going to revolve it around the equation y equals 2, right here. You see that line? Okay, so y equals 2.
That one's a mole.
Not this one, but we're going to talk about ones that have.
Whoa.
Okay, because this one is, this whole area is butted up against that center point. So it's still a pizza.
Like a half sphere, isn't it?
Oh, I see what you mean, like the 3-dimensional shape.
Yeah.
Oh, yeah, you're right, it is a bowl. Okay, so let's set up our integral. Okay, so what is the x value that these exist between? Okay, so we have the volume of pi, the integral to 0 to 2. Okay, now be very careful here. What is my r? Okay, very good. Okay, so it's going to be a top. We got to cancel out this bottom part. So this is a top minus bottom scenario, just like when we learned for the area between 2 curves. Okay, so it's going to be negative x squared plus 6 minus the straight line, which is 2.
So could you just put negative x squared plus 4? Or is that not okay?
No, that would be fine. Uh-oh. Plus, oh, no. My pen. Gosh dang it, this just... Okay, hold on for a second. Did my video die? Recording.